Hello, and thank you for joining me. We're going to look at sum and difference formulas, and we're going to be looking at the cosine version of sum and difference formula. So namely, cosine of A plus B is going to be equal to cosine A cosine B minus sine cosine B. Now, if you've watched my video for sine formulas for sum and differences, then you would have noticed that when this is a plus, this is also a plus. But with cosine, it switches. It's a good reason why it does is mainly right now just accept that it does. We can go through a long process and explain why it switches, but right now the big thing to realize is that it does actually switch. A little bit deeper of an issue has to do with odd and even type functions, namely that cosine is an even function and sine is an odd function. Oh, I messed up a little bit. Everybody see where I messed up? That's supposed to be sine. Sorry about that. All right, so what do we got here? So what this means is that if we take two angles and we add those two angles together inside of a single cosine function, we can actually split that up into being two separate ones. Now, like I said on the previous video, and I'm going to add a little bit more detail here, is that this really was very useful to us before we had calculators. And we couldn't necessarily evaluate something like 105 degrees. The unit circle doesn't have that on there, but it does have 60 and 45, which add up to 105 degrees, which is where this trig function comes into play and why it's useful. We also have a subtraction version of this, cosine of A minus B, and it is identical except for one small piece, which is this is a plus sign here. Everything else is the same. Okay. Now, so let's say that we were talking about cosine of 105 degrees, which I already mentioned can be rewritten as cosine of 60 plus cosine of 45 degrees. Now, those two measurements are on our unit circle, so we can use the sum formula for cosine right here to rewrite this. So that'd be cosine of 60 degrees, cosine of 45 degrees, all right, minus sine of 60 degrees, sine of 45 degrees. And then I just think about my unit circle, and here is 45 degrees, and the angles there are the coordinates there are root 2 over 2 and root 2 over 2 for x and y. And there are 60 degrees. I know you can't read that very well, but that's 60 degrees, and that's 1/2 and root 3 over 2. Now we just use those known values on the unit circle to finish this evaluation. Cosine of 60 is 1/2, cosine of 45 is root 2 over 2, and then minus sine of 60, which is root 3 over 2, and sine of 45, which is root 2 over 2. All right? So what we have there is everything we need to do to finish evaluating this, which is root 2 over 4 minus root 6 over 4, because these are fractions, so we just multiply straight across. Now they have a common denominator, so I can just combine the two fractions into one fraction, and now I have the exact value. Now, how does this help us? Well, if we have the exact value, we can get a calculator and find the approximate value. We could have gone back to this and done that with the calculator as well and found the approximate value. Now, you could also approximate this. If you think about this, cosine of 90 degrees, well, that'd be on the unit circle, 90 degrees is at the top, so the coordinates there are 0, 1. So you think that cosine of 105 is going to be something close to 0. And it'd have to be negative because it'd be in the second quadrant. So it's a negative something or other. And if you look at this, you do end up getting a negative. So it's root 2 minus root 6. So that is 1 point something minus 1 point something. And then divided by 4, right? So, or 2 point something rather. So you do end up with something that is less than 1, or less than 0, in fact. And that's what we're looking to establish. So the big thing you got to remember is that, yes, this gives us an exact value, but also this gives us the ability to do this symbolically, which means that instead of going up and doing 105, we could do A and B. And then that allows us to be able to deal with and attack trig functions symbolically and use this information to evaluate a proof, maybe, or establish an identity of some sort, or just to play around with things. But these sum and difference formulas are very useful to us And you get deeper into calculus, and there's some different formulas for sine and cosine can be useful there too, because they allow us to be able to rewrite formulas in one way that maybe we can't evaluate it, but when we get it into this other format, maybe it does allow for evaluation for a derivative or a integration of some sort. All right. So again, thank you. You can click the like button if you enjoyed this and you found it useful. Feel free, please subscribe to my channel, and I'll see you in the next video.